The last two things in this section deal with monotonic sequences and bounded sequences. So let's define what that means. A monotonic sequence is going to be a sequence that is non-decreasing. So a sequence that is non-decreasing, which means a sub 1 is less than or equal to a sub 2, which is less than or equal to a sub 3, which is less than or equal to a sub n, meaning a sub n plus 1 is greater than a sub n. Another way of thinking about non-decreasing is increasing. You want to think increasing, but you can't really say increasing because of those equal to, because if it's the same number over and over again, that is also something that's monotonic. Or you can say that something is monotonic if it is non-increasing, which again, I want you to think decreasing. Basically, a sequence is monotonic if the numbers are always getting bigger or if the numbers are always getting smaller. And because of the equal sign, we also say if the number remains the same. That's something that's monotonic. Now, a bounded sequence is a sequence that's going to be trapped by a lowest and or highest value. A sequence is bounded above when there exists some real number m such that a sub n is less than or equal to m for all n. If you think about it as a picture, and we're going to draw some random sequence here, and we're also going to draw on this horizontal asymptote here for m. So let's say that this was my sequence. My sequence is this guy here. Notice that it's never going above m, therefore this sequence is bounded above by m. A sequence is bounded below where there exists some real number n such that a sub n is greater than or equal to n for all n. If we were to draw a picture of that, we'd have another horizontal asymptote. We're going to make this one a little lower. We're going to call this guy here n. And then I'm going to draw another sequence in here. Notice I'm never getting below n. Since I'm never getting below n, I am bounded below. Now a sequence is considered completely bounded where it's trapped between two numbers. This sequence that I'm about to draw is going to be bounded between m and n. Basically, what that means is that the highest or the lowest this sequence ever is bounded between two numbers, in this case m and n. Again, bounded above means that the sequence has a largest number that it never surpasses. Bounded below meant that there's a lowest value you never surpass. And bounded completely means you were trapped between two numbers. Now, any sequence that is both monotonic and bounded will converge. Because if you think about it, if you have a sequence that is always increasing and it's bounded above, then it's got to be converging towards a number. Or if you have a sequence that's always decreasing and it's bounded below, then the sequence will converge. Any sequence, again, that is bounded and monotonic will converge. How do you determine if a sequence is monotonic or if a sequence is bounded? Well, to determine if a sequence is monotonic, you have three different ways to look at it. You can find the derivative of the sequence, and if you can show that the terms are always positive, we'll think derivative gives you slope, always positive means that you're always increasing, or always negative, and again think always negative means your slope's negative, which means you're decreasing. You're going to be monotonic. Another way to determine if you're monotonic is to compare a sub n and a sub n plus 1. So if you're comparing a sub n and a sub n plus 1, if a sub n is greater than or equal to a sub n plus 1, if the one before is always greater than, this would mean that you are decreasing. And then if a sub n is less than or equal to a sub n plus 1, this means you are increasing. So if you could show that this inequality holds or this inequality holds, you show that you're monotonic. The last way of doing it is by just writing out the first few terms. You typically do this when you have something that's negative raised to the n. And that way you can show that I'm oscillating between positive and negative, so there's no way that I'm always increasing or always decreasing. That's how you determine if you're monotonic. How do you determine if you're bounded? To determine if you're bounded, the first thing you do is you find the first term of your sequence. Remember, your first term happens when n is equal to 1. Then you take the limit of the sequence. Remember, to find the limit of the sequence, you have to take the limit as n goes to infinity of a sub n. If both values are numbers, so that means that you were ending up getting a value when you plugged in n equal 1, and you got a limit for your sequence so you didn't diverge, then you are going to be bounded. So let's determine whether the sequence with the given n term is monotonic and whether it is bounded. Starting with number 11, I have a sub n is equal to 2 minus 1 over n. I like to, if I can, just take the derivative to figure out if things are monotonic or not. When I take the derivative, I rewrite things as functions. So instead of n's, I'm going to write an x. If we think of this as a function, f of x would equal 2 minus 1 over x. If I were to rewrite it with a negative exponent so it's easier to take the derivative, I'd have 2 minus x to the negative first. Finding the derivative, I would end up with, well, the derivative of 2 is 0, and the derivative of negative x to the negative first would be positive 1 x to the negative second, or without a negative exponent, 1 over x squared. Well, look at this derivative. The number 1 is always positive. And then x squared is, again, always positive, because if you take something and you square it, you're always positive. Well, a number that's always positive divided by a number that's always positive equals something that is always positive. So if you're always positive, if your derivative is always positive, that means that the sequence is always increasing. And if you're always increasing, therefore your sequence is monotonic. Well, is this sequence bounded? To determine if you're bounded, you have to find the first term in the sequence. A sub n, since we can't see it anymore, is 2 minus 1 over n. So a sub 1 would be 2 minus 1 over 1, or 1. This guy's a number, so far so good. Then we have to take the limit as n goes to infinity of a sub n. Well, what's the limit as n goes to infinity of a sub n? Well, that's going to be 2 minus 0, which is 2. That's equal to a number because this was a number and this was a number, therefore this sequence is bounded. So this sequence we would say is monotonic and bounded. What about example 12? I have a sub n is equal to negative 2/5 to the n. I can't take the derivative here because for our particular derivatives, when we're looking at exponentials, when we did this derivative before, the derivative of a to the u was, remember, a to the u times the natural log of a times u prime. Well, this requires a to be greater than 0. This number here is not bigger than 0. Since it's not bigger than 0, then I would have negative 1 to the n times 2/5 to the n, and then I'd have to try to take its absolute value, and it would just be a mess. So finding whether this is monotonic using the derivative isn't really going to work. Comparing terms as well is really difficult, especially when you have a negative being raised to a power. In these scenarios, when you have a negative, it's best to list the terms to determine if you're monotonic. We're going to just list terms to determine if we're monotonic. Let's see what our terms are. A sub 1 would be negative 2/5 to the first power, or negative 2/5. A sub 2 would be negative 2/5 to the second power, 4 over 25. All right, well, we're increasing so far, so that's not a big deal. What about a sub 3? Well, a sub 3 would be negative 2/5 cubed, which is negative 8 over 125. Well, wait a second, now we're decreasing. Since we switched from increasing to decreasing, we know that we are not monotonic. Remember, something is monotonic if it's always increasing or if it's always decreasing. If you're going between increasing and decreasing, you are not monotonic. Usually if you have a negative raised to the nth power to determine if you're monotonic, it's best to find the first few terms. What about bounded? Well, remember, with bounded, we have to start by finding the first term. Well, we already found the first term. We know that a sub 1 was equal to negative 2/5. We found it right here. Well, that's a number. Now we have to figure out what is the limit as n goes to infinity of negative 2/5 to the n. Well, what is negative 2/5 to the infinity? I'm not really sure. And this guy has, remember I said it's equivalent to a negative 1 to the n times 2/5 to the n. So let's go ahead and find the absolute value of a sub n first, and then see if that's going to 0, because if that's going to 0, then I know that negative 2/5 to the n would also be going to 0. If I find its absolute value, the absolute value of this guy, I know that this would go away, and this is just 2/5 to the n. So now what is the limit as n goes to infinity of 2/5 to the n? Maybe we're not sure. It's 2/5 to the infinity. Is that infinity? I don't know. The easiest way to determine this is to look at its graph. So if we grab a graphing calculator and we put in 2/5 to the x in the graph, 2/5 raised to the x, and hit enter, and graph, as our x's here are approaching infinity, notice that we're trying to get closer and closer to y equals 0. This is a decreasing exponential function, so it's trying to get closer and closer to y equals 0. Therefore, I know that this limit, 2/5 to the infinity, is equal to 0. Now remember, the absolute value theorem for sequences said if you took the absolute value and took the limit as n went to infinity of the absolute value of the sequence, and that was equal to 0, that meant that the limit as n goes to infinity of negative 2/5 to the n would also equal 0. And since this guy here is a number, that means that we are bounded. This particular sequence is not monotonic, but it's bounded. So it's possible to be bounded and monotonic like we are in example 11, not monotonic and bounded like we are in example 12. You could also be monotonic but not bounded, and then it's possible to be not monotonic and not bounded. That's it for sequences.